Alright, what's up guys? Today I'm going to be going over the Algebra 2 Honors Unit 2 test review. I'll just go over each question and I'll work them out so that you guys will be prepared to take the test on Wednesday. I'm uploading this Monday night, so hopefully you guys will have enough time to view this video and prepare. But we'll start with question 1. Question 1 is asking us to solve this matrix subtraction question, meaning we're going to have A minus B minus C. So the best way to start this is to just write each matrix to see what's going on. So we know that A is this one, so we're just going to write it as is. And it's going to be A minus B, so we know that B is this one in red. So it is 6 minus 4, 10, and 0. And finally, we know that C is this one over here. Let's see if I could fit it without making too much of a mess. 6, negative 5, and 7. Okay, so what this is basically asking us to do is subtract each one of these. So I'm going to start by subtracting these two matrices, A and B, and then dropping C down. So that means we're going to have something like this. So we're going to do 2 minus 6, which is a minus 4. So you subtract the elements with the same address in the matrix. And we do 2 minus a minus 4, which is a positive 6, because the two minuses make a plus. Then we do 1 minus 10, which is a minus 9. And then minus 3 minus 0, well, that means we didn't change it at all. So that's just minus 3. So lastly, we're left with these two matrices that we need to subtract. And then from here, we just do the same process. This is equal to negative 4 minus 11, which is just minus 15. Then 6 minus 6, that's 0. Minus 9 minus a minus 5. So that makes it minus 9 plus 5, which is minus 4. And then minus 3 minus 7, which is a minus 10. And this would be our answer. New matrix with minus 15, 0, minus 4, and minus 10. So question 2 is pretty similar, but instead of subtracting a bunch of things, we're going to be adding and scaling this B matrix. So we wrote it in red, so we're going to do 2 times, then this B matrix in red. Yeah, let me just underline it in red so that we know that that's what we're talking about. 6 minus 4, 10, and 0. All of that is going to be plus A, which we circled in blue right here. 2, 2, 1, minus 3. And the way that we do these is it's pretty similar to PEMDAS. We do the multiplication first and then we add. So we're going to do the scalar multiplication first to each one of the elements inside the matrix. Meaning we have a 6 times 2, which is a 12. We have a 2 times a negative 4, which is a minus 8. 2 times a 10, which is a 20. And a 2 times a 0, which is just 0. And from here, we have just the same matrix. And now that we scaled it up by 2, we can properly add these two matrices. So that's going to be equal to 12 plus 2, which is a 14, minus 8 plus 2, which is a minus 6, a 20 plus 1, which is a 21, and a 0 plus minus 3, which is just minus 3. Let me just double check to see if I made any mistakes. No, it looks good. No mistakes. So we'll just box in our answer because that's our final matrix. And number 3 is pretty similar. We'll just work on it super quick. Hopefully it doesn't take us too long. We'll just write down each matrix. 2, negative 3. It's going to be minus... Oh, whoops. It's going to be 2 times C, which is minus 11, 6, minus 5, and 7. So again, we're going to multiply the 2 into the matrix, meaning this 2 is going to go to each element. So that means this first matrix stays the same. And it's going to be minus, it's going to be this matrix times 2. So negative 11 turns into negative 22, turns into 12, turns into minus 10, turns into a 14. From here, we just subtract both matrices. First, we multiplied C times 2, and now we're subtracting A minus the new matrix. So 2 minus a minus 22, that's like plus 22, so that's 24. 2 minus 12 is minus 10. 1 minus a minus 10 is a plus 10, so that's 11. Finally, negative 3 minus 14 is minus 17. There you go. Not that bad at all. It's just a bunch of adding, subtracting, multiplying. Just being careful with negatives and positives. So this is questions 4 and 5, which is asking us to solve systems of equations algebraically. It's giving us the option to use substitution and elimination. So in the test, you'll be able to use either or. So in this one, I'm going to use substitution just so that you get some practice with it. So in order to use substitution, one of the lines needs to be an x equals or y equals. I see that if I label it, equation 2 looks very simple. So I want to get equation 2 and I want to manipulate it so that it looks like it's in x or y equals. All we have to do is move this y over to the other side by adding plus y on both sides, giving us a new equation of x equals 13 plus y. And now that we have this new equation, we can plug in this value for x. Because we have x equals 13 plus y, we know that x is the same as 13 plus y. So anytime we see an x, we can replace it with full confidence, knowing that we're not breaking any rules. And so up here, I'm just rewriting equation 1. And we notice that there's a little x here. So we could kind of get this whole x and replace that whole thing. And then replace x with that whole thing. So we get a new equation 4. And it's times x, but it's not the same x. It's 13 plus y plus 2y is equal to 10. And now that we substituted it, we can effectively solve for y because we only have y variables in this equation. So the steps are pretty straightforward. We usually want to distribute. So 13 times 4, that's like 40 plus 12, which is 52, plus a 4y plus a 2y is equal to 10. Next, I'm going to do a two-step. I'm going to combine these two y's. So 4y plus 2y is going to be 6y. But I'm also going to subtract this minus 52 to both sides. So at the end we have a 6y is equal to 10 minus 52 is minus 42. The last step would be to divide by 6 like this. Next, we just evaluate y is equal to negative 42 divided by 6, which is a negative 7. Okay, so that's our y value. Now we want to find our x value. And the easiest way to do it would be to plug it into one of these equations. Since we already have equation 2 in the form of x equals, then it would help us to just plug in y for that. So if we plug in y into that equation, we get 13 plus... And then in a similar way, we're substituting the value of y with negative 7. So this gives us x is equal to 6. Perfect. And you could always plug these values in to equations 1 and 2 up top to see if it makes sense. But I can just see that if we do 4 times 6, which is 24, plus 2 times negative 7, which is negative 14, 24 plus 2, or 24 minus 14 will give us 10. So that's the quick calculation that I did in my head. I'll write it out just to be explicit about what I'm doing. But this is just a check. So we're plugging this into equation 1. And if this is true, then that means we got our answer right. Minus 14, which is equal to 10. And that looks like it's true. 24 minus 14 is 10, which means we got 10 equals 10. So a lot of people seem to prefer elimination. So we're going to go over that example as well. And then you'll have the option of choosing which method you want to do. So here, the way that we do elimination is we want to multiply one of the equations by a factor so that when we add the equations together, variables can cancel out. So already I want to multiply equation 1 because I notice that, well, the y's don't really have a common factor that's easy to think of. So I don't want to multiply for the y's. But I see that the x's, we have an x here and a negative 16 here. So if I multiply equation 2, or equation 1 rather, by a times 2, then that means each factor or each term is going to be multiplied by 2, giving us a new equation of 16x minus 12y is equal to negative 40. Now we add this. Now it's important to keep in mind that both equations 1 and 2 are already in this form. Hopefully remember that this is called standard form. And if it's in standard form, then that means you can do elimination method very quickly. If it's not in standard form, then you may have to make it look like ax plus by is equal to c, but that shouldn't be too much of an issue. So from here, we're going to add equations. Oh, I'm sorry. I meant to write equation 1 right here. We're going to add equation 1 and 2. So we can kind of ignore this top one now. So now we have minus 16x plus a 16x. That's a 0x. So that's just 0. That's just 0 times x. Then we have a minus 12y plus a 7, which is minus 5y. That is equal to minus 40 plus 30. It's minus 10. So this gives us a value right here. If we divide both sides by minus 5, this one was a lot quicker. So y is equal to 2. Maybe I see why you guys like elimination more now. And from here, we can plug this y value into one of the equations. You can plug it into equations 1 and 2, but for now, I'm just going to plug it into 2. Doesn't really make a difference which equation you plug it in. Plus 7y, but in this case, it's not y, it's 2. Is equal to 30. So this is giving us negative 16x plus 14 is equal to 30. Finally, when we subtract this 14 to both sides, I'm going to do a little arrow because I ran out of space. We have minus 16x is equal to 16. Or if we divide both sides by negative 16, we get an x is equal to a negative 1. Giving us our answer. Perfect. So hopefully you'll be comfortable with either one of these methods. From here, we'll continue to these next questions. So 6 and 7, they don't really require too much math at all. But let's look at 6 for now. So it's giving us this matrix, and it's asking us which of it represents the matrix below, or which system of equations represents the matrix. So what we want to do is we could consider each row one by one. And each row is meant to represent an equation. So if we take row 1, then that means we have 3 times x minus 5 times y, which is equal to 13. So that means we get 3x minus 5y is equal to 13. If we take a similar approach for equation 2, we get 2x minus 7y is equal to 81. So 2x, a plus 7y. Plus 7y is equal to 81. It's a positive 7. So all we have to do now is see which equations line up with the ones that we wrote right here. And if they don't line up, then we just scratch them off. So 3x plus 2, this one's wrong, so we know it's not A. 3x minus 5 is equal to 13. 2x plus 7 is equal to 81. So this one looks pretty good. I'll just circle it. But let me just check the others just to make sure. 3y minus 5x? No. 3x minus 5x is equal to 13. Oh, x and x, y and y. No, that's wrong. So it's B. So which of the following matrices best represents the systems of equations below? So what I'm actually going to do for these equations is rewrite them, because we notice that the z is not on the right side, the z is not on the right side, and this 12 and the z again is not on the right side, on the correct side, not on the actual right side. So that means to move that plus 7z means we'd have to do minus 7z. So I'll erase this to give myself a little bit more space, but if we do minus 7z to both sides, let me rewrite my work. 7z, that means this cancel out on this side, so that means we have x minus 4y minus 7z is equal to 13. Do a similar process for the second equation. We'll do a plus z on both sides. Keeping in mind that we don't have any x's, so we could just write a 0x. No x's means 0 x's. Plus the 7y that's already there, plus the z, which is equal to minus 8. Finally, here we have to subtract the 12 on both sides, and then add this 5z on both sides, giving us minus x plus 5y plus 5z, which is equal to 12. So it's a similar process. We're just going to go row by row on each of these questions and see if it represents the coefficients of our systems of equation. So the first equation, it should be 1x minus 4y and minus 7, 13. So it looks like they all have it. 1x minus 4 and 7, 1x minus 4 and 7. Boom, boom. Oh, so actually this one's wrong because it should be a negative 7. So we could scratch out the first one. It's a minus 7z. So this one had a plus 7z. Okay, so the next row, I see that we have 0 x's, 7 y's, and 1 z. I can see that this shows that we have 7 x's, 1 y, and 0 z's. So we can also say that that one's wrong. Finally, this last one says we have minus 1x and a plus 5 y's and plus 5 z's, giving us the correct answer for B. This one has a plus 1, a minus 5, and a minus 12. So none of the right values.